Hello everyone. Today we are going to start a new chapter, and this is now we see the universe in a new light that I am going to discuss with you. You see here, that is now we see the universe in a new light. Hello. Hello everyone. Today we shall discuss about work, energy and power, an introduction to the currency of the universe. You see, this is the work, energy and power, introduction to the currency of the universe. We are going to learn about this work, power, energy. Beyond forces, a more powerful way to see the world. You see this one, that we have used forces and acceleration, Newton's second law to describe how things move moment by moment. You see, suppose this is an object and this is the normal reaction, this is the mg, weight of the object, this is the applied force, this is the frictional force opposite to this. The moment by moment analysis. You see here, this is the initial energy ei, the final energy ef. Therefore energy provides a new lens. It's an integral form of Newton's laws that tell us the why and the what of an entire journey. Think of it as the universal currency that is exchanged and conserved in every physical interaction. Total journey analysis. You see, the work, the act of transferring energy. Core concept. In physics, work is not about effort. A weightlifter holding a 150 kg mass steady does no work. Work is the transfer of energy by a force acting over a displacement. It is the transaction. Key formula of force work is equal to F dot D. F dot D force is F is a force and is a displacement, and we know that it is modulus of F modulus of D into cos theta, where theta is the angle between the force and the displacement vectors. Work is a scalar quantity. It can be positive, energy added, or negative, energy removed. No work is done if displacement is 0, pushing a wall. Force is 0. Force is perpendicular to displacement with theta equal to 90 degree, like gravity acting on a block sliding on a horizontal table. So these are the various cases of no work is done. Now we learn the other thing, that this one, kinetic energy, your cash on hand. Core concept. Kinetic energy is energy an object possesses by virtue of its motion. It's a measure of the work an object can do because it's moving. The more mass and speed, the more spending power it has. The formula is K, key formula is K equal to half mv square. Key points, kinetic energy is scalar quantity. It is always positive. Here the bullet 1000 joule, car 12,500 joule, earth 2.7 into 33 joule. The work energy theorem, transactions change your balance. The change in the kinetic energy of a particle is equal to the work done on it by the net force. A positive net work increases your cash. A negative net work like friction depletes it. The work net, it is equal to del K, that is changing kinetic final minus kinetic initial. W net, positive work. Kinetic energy amount, Kf minus Ki. Potential energy, kinetic energy account. Case study, 1 gram raindrop, work by gravity deposit 10 joule. Work by resistive force withdrawal minus 8.75. The net change in kinetic energy del K equal to 1.25 joule. That is del K change in kinetic energy, and that is equal to work. Potential energy, your savings account. Core concept, energy can be stored based on an object's position or configuration. This stored energy is called potential energy because it has the potential to be converted into kinetic energy. Gravitational savings account, V equal to mgh, gravitational savings, this is mgh. If we take this ball to this height, the potential energy will be mgh. Elastic investment account, it is elastic potential energy. If we take this spring and extend from its equilibrium position x, then it is elastic investment and it is x square, and potential energy half k x square. Conservative forces, the perfect bankers. Core concept, a force is conservative if the work it does on an object moving between 2 points is independent of the path taken. Forces like gravity and the ideal spring force are conservative. They reliably store and release energy. The banker's promise, del phi is equal to minus Wc. Key property, the work done by conservative force over any closed path is always 0. You see here, it depends only on the, it does not depend on the path, it depends on the initial and final position. This is path 1, path A to B. It depends on only the initial and final position, but doesn't depend on path. The withdrawal from your gravity savings account is mgh, no matter which path you take. That is mgh. And the second one is this one, that Mustard law, your total wealth is constant. In an isolated system where only conservative forces do work, the total mechanical energy, the sum of kinetic and potential energies, remains constant. Energy simply converts between kinetic phase and potential savings. Kinetic initial and kinetic potential initial equal to kinetic final plus potential final. That is total mechanical energy will be conserved. Total mechanical energy equal to total kinetic energy plus total potential energy. The transaction fee, friction and drag. Not all forces are conservative. Forces like friction and air resistance are non-conservative because the work they do depends on the path taken. They remove mechanical energy from the system typically by converting it into thermal energy. W. Therefore, we get daily change in kinetic energy plus change in potential energy. There is change in energy. Total mechanical energy, energy lost due to heat. Kinetic energy, potential energy. In this way, we find the transaction fee, that is friction and drag. Power, your gas flow. Core concept, power is the time rate at which work is done or energy is transferred. It's not about how much energy you transfer, but how fast you transfer it. Key formulas, average power equal to work done by time taken. Instantaneous power equal to dW by dt, that is equal to F dot V. Units, the SI unit is a watt, where 1 watt equal to 1 joule per second. An elevator motor requires 44,000 watt to lift a full load at 2 meters per second. This is the required rate of spending. Same work, different power. Work is same, but power is different. Power A and power B, 2x power A. In 10 seconds, it lifts. It 5 seconds it lifts the whole object. Therefore, the power is double. Right? The same time power is that is power is more here. Right? So in this case, you find these are the. In this way, you can find collisions, the transfer of wealth. Core concept. Collisions are interactions where momentum and energy are rapidly exchanged. The key to analyzing them is to identify which qualities are conserved. The universal rule, in any collision isolated from external forces, total linear momentum is always conserved. The deciding factor, the total kinetic energy may or may not be conserved. This is what defines the type of collision. There are three types of collision. You can say elastic, inelastic and completely inelastic. If it is elastic collision, momentum is conserved. Kinetic energy is also conserved in elastic collision. In case of inelastic collision, momentum conserved, but kinetic energy is not conserved. In completely inelastic collision, momentum is conserved, but kinetic energy is not conserved. Case study, perfect exchange, elastic collisions. A collision in which the total kinetic energy of the system is conserved. Initial kinetic energy equals the final kinetic energy. Initial kinetic energy is equal to final kinetic energy. A special case, equal masses 1d. When a moving object has an elastic head-on collision with an identical stationary object, the first mass comes to rest and the second moves off with the initial velocity of the first. You see, with this experiment, a lossless transaction. Case study, a costly merger inelastic collision. Definition, a collision in which kinetic energy is not conserved. Some kinetic energy is transformed into other forms like heat or sound during object deformation. Total kinetic energy before. Completely inelastic collision. The objects stick together after colliding and move with a single final velocity. The cost. The loss in kinetic energy del k equal to m1 m2 by 2 m1 plus m2 b1 square is always a positive value representing an energy cost. You see total kinetic energy before. After total kinetic energy loss to deformation, heat and sound. The grand unified view of energy. This is the total energy. Cash on hand, kinetic energy half mv square. Savings, potential energy mgh half k x square. Work done, force into displacement. Conservation of energy in a conservative system, total wealth is constant. Kinetic energy plus potential energy equal to constant. Power F into V. the speed of the transaction. Non-conservative forces, friction, real world fees that reduce mechanical energy, WNC is equal to del E. Now we see the universe in a new light. And this is not just a chapter in a textbook. It is a fundamental lens for understanding everything from the collisions of billiard balls to a comet's journey around the sun. The principle of its transfer, storage, and conservation shape the physical world at every scale. Questions. This is the question. So, dear friends, if you like this video, please subscribe, like, and share. Thank you everybody for watching this video.